So I think I will give a small briefing about the machine-to-machine communications and cyber physical systems in the first part of today's lecture. And in the second part, I will start discussing about uh, technologies related to network virtualization and how the network virtualization will enable the IoT communications and IoT networks. So, network virtualization is something that is one of the enabling technologies of IoT. So, in the last class, we have discussed about several enabling technologies for IoT systems and IoT networks. So, those technologies included wireless networks, cloud computing, machine learning, big data analysis, so on. So one of those technologies will be a network virtualization, and we will be discussing those technologies in the latter part of today's lecture. So first of all, starting off with the machine-to-machine communications, I think this is basically a terminology that is used to um, define the communication that um, that can enable exchange of information between uh, two machines or two devices, and uh, that communication will happen without any invention from other parties. So if we take the situations where, for example, where we have communication between two robots in an industrial environment, we have machine-to-machine communication over there. So there are some, advanced technologies involved here. So in order for the direct communication to happen properly, the technology of the communication technology that is used must be reliable, and the communication of data must be reliably done, such that the machines who are receiving the messages are receiving the correct information and do the necessary tasks based on that information. So, however, machine-to-machine communication is vitally important communication uh, based based on which is based on IoT principles. So this machine-to-machine communication is useful in situations where we want the machines to work on their own without instructions or without any kind of support from an outside human or a network infrastructure. So the examples include factory automation, right, where we are automating the robots functioning in a factory, and we expect the robot to work on their own based on the information that it receives. So the robot might receive different information from the environment, and based on that data, it will work and it will make some decisions. Apart from that, we have smart monitoring systems. So smart meter readings that does the reading of different parameters, such as water flow or else electricity usage, that kind of metering. So in such kind of smart meters also, we can see machine-to-machine communication, where the smart meters are discussing or communicating between each other directly, um, for I mean, to achieve different tasks. So maybe like smart meters like can communicate with each other to like gain more information about the situation of the system, and based on that it can correctly monitor the amount of usage in certain part of the system. So based on that, the main system or the centralized system can gain information and make some decisions about, make some determinations about the usage of the entire system in terms of electricity, in terms of water, and so on. So machine-to-machine communication is a technology which is based on IoT, but less it's less connected to the rest of the world. The machine-to-machine communication is kind of applied in local networks, in a small scale network, and it is used for direct communication between two devices, two machines, or two robots, likewise. So IoT is a much more advanced concept than M2M, where the IoT enables communication between the devices and the internet. So the devices can connect themselves to the internet. Whereas in M2M, we cannot ensure that connection to the internet is established, right? So we cannot ensure that the connection to the internet is established in the M2M communications. And the M2M basically establishes the communication within the local area network. Right. So in the IoT, of course, I mean, another difference in the IoT will be that the types of devices that are communicating in the IoT are different, or we can connect different types of devices into the IoT network. Whereas in M2M, we normally connect same type of devices for communication, which means uh, that you can connect basically robots. If you are considering robots, you like establish the communication between robots only. And if you want communication between other two devices, those two devices must have some equal properties. They should be homogeneous. So when you talk about the IoT networks, you can construct the network between different heterogeneous devices, and you can establish the communication between all those different types of devices. When you talk about the cyber physical systems are much more enhanced than IoT and M2M, whereas the cyber physical systems are systems which are systems that are available um, um, available at the edge of the network. I mean, cyber physical systems actually consist of uh, systems that can autonomously monitor and control complex physical processes. So it's actually something that is um make decisions and control some processes at the edge of the network, for example. So uh, if I am to explain that, I think I can, explain a situation where you have some kind of an industrial process happening in some kind of a factory or a industry. And in the cyber, if you have the cyber physical systems and the technologies related to that, then that industry can automatically make decisions that at the process, at the industrial environment, at the environment, at the at the processes where different processes are happening in the industry. So for example, if you have a soap manufacturing industry, let's say, if you are for example, if you are mixing some ingredients, and if you are producing soap, then that entire process of making soap is controlled by autonomously by this cyber physical system and the related controllers. The controllers which are available in the cyber physical systems are able to monitor the process and make decisions about the process and also control the process. So therefore, the cyber physical system is something that humans don't need to intervene, and the cyber physical system can work on its own. However, the human also can monitor the entire process of the system, maybe in a centralized manner or in a decentralized manner. So basically, when you compare with the IoT systems are much less, involved in the processes that are happening at the edge of the network or at the application level of the network. So IoT is basically making monitoring. It's making some observations about the network, which is available at the edge of the IoT, and then it's giving the information to maybe edge server, or it's giving the information to a cloud server. So it is basically, transferring data. It is collecting data and transferring data, and again receiving data, and again transferring data back to the IoT devices. It is basically communicating the devices. Whereas if you compare with the cyber physical systems are not only transferring or communicating data from one place to another, it also makes some, decisions, and it is doing the work at the edge of the network. It is controlling a process at the edge of the network. So the controlling part is also done in an autonomous manner at the edge of the network. However, this autonomous controlling can also be monitored and also be, controlled at a centralized server by a human. Right? Humans can control the process that is happening at the edge, but the cyber physical systems are also capable of, controlling those processes on their own. So cyber physical systems is something that is currently in trend. It is not exactly implemented in a large scale, for example, in many countries in the world. But we hope that it is going to be something big in the upcoming future. So these are the kind of evolutions of IoT. And basically, we started with the M2M, or direct device-to-device communications, and then we have expanded it with IoT, and then we have now come up to cyber physical systems. Right, so the scale of the communication has expanded, and it has come to a level that the system can function on its own without the human interventions. So if we consider the M2M architecture, the M2M communications or machine-to-machine communications will basically is the communication that is happening within a certain local network or a small scale uh, local area network. Right, so in here we can do the communication between two devices directly, and most of the time the devices that are communicating in the M2M will be homogeneous devices, which means that they are same type devices. So we can communicate, or we can create a M2M network like that, and after that we can also connect the M2M network to certain network infrastructure using an M2M gateway. So the M2M communication also can be connected to to a certain network infrastructure, and then to the local, like, servers, or maybe some kind of core networks. If required, we can do it, or else they can also function on their own in the local network. Right, so once we connect this M2M network into the internet, it will actually become an IoT network. Then in here, the another type of devices are connected to the M2M core networks. So if we can connect our networks, our local M2M networks into the internet, then we can consider that as a IoT network. So M2M can be extended to IoT networks. And IoT also, when we looked at this um, kind of different types of evolutions, we can see that IoT also can be extended into cyber physical systems. So these are kind of improvements that can happen on IoT networks. So M2M can be extended into IoT, and IoT can be extended into cyber physical systems. So when we talk about the differences between IoT and M2M, we can see that different differences are observed in the communication protocols. Um, and when we talk about the protocols, basically the communication protocols that are used in M2M will be the communications that can be done via direct communication link. So the direct communication link can be established using basically Bluetooth, Zigbee, LoRa, and Modbus is also another communication technology that is used in factory level robot to robot communications. So these are some of the communication technologies that can be used. Right. Apart from that, actually, when you're going with the IoT, IoT specifies specifically concerns about the protocols that enables the IoT network to connect to the internet. So on top of the Zigbee, Bluetooth, LoRa, and other Modbus and other short-range communications, IoT protocols include HTTP, COAP, WebSocket, MQTT, and so on. So when you talk about the network and the type of the network that is established in the communication and the M2M communications is going to be a homogeneous network, which means that same type of devices are connected together into a network. And then when you consider the IoT networks, different types of devices can be connected into the IoT network, which means it is a heterogeneous network. Then M2M communications rely more on hardware, whereas IoT rely more on software. And the M2M net communication, most of the time, does the communication in a local network, on a local area. And the IoT devices or IoT networks are basically doing the communication with the internet, and the data can be stored in a central cloud server. The data analysis can be done in a cloud server, and the cloud servers are having more resources to do the analysis. And therefore, in IoT, we can use the cloud servers to do the analysis part. So that is right. So cloud servers are useful when you have a lot of data to analyze. Then M2M communications and M2M applications can be accessed by on-premise subscribers, and IoT applications can be accessed by cloud or any cloud or any internet user. So what we mean is that M2M applications or M2M communications can be accessed by local network users, whereas IoT networks can be accessed by wide area network users. So I think with that we have discussed about the M2M communications and IoT and the cyber physical systems. So we have discussed about the different differences that are there between those three systems. So these are basically the kind of the versions of different IoT networks, or different versions of the interconnected devices that the devices and the different technologies related to that have been introduced so far. So I think with that, I think I will end that session about the direct communication between devices. I mean, M2M communications. So we have discussed about M2M communications. We have discussed about cyber physical systems. So that is also required for us to understand about the IoT networks. So moving on, we will discuss next about the next network virtualization. So uh, before doing that, I think I will try to share the attendance monitoring with you. So if you have any questions, let me know. Uh, I have another announcement to make about the IoT classes. Would it be okay for you if I conduct the interactive, 2-hour class during Tuesday evening from 8 to 10? Today, actually, today from 8 to 10 p.m. Uh, Actually, I'm asking you mainly because I'm already, doing another lecture for the lateral entry students. There are only 2 students there. So since I'm doing the same class 2 times, I was thinking of doing the content of the interactive class during that time. And also I will be available at the, lecture room, FF2, I think, on Fridays. If you have any questions, you can come and meet me there. The content I will deliver on Tuesday evening. So will it be okay with you or not? Tuesday 8 to 10, I will be having that. So yes, okay. Thank you, Yasas. So uh, about others, maybe Jitmal, can you maybe ask from your friends? Can you let me know whether they can join on Tuesday from 8 to 10 for the interactive class? Also, I want to let you know that I will anyway be there on Friday. On Friday 2 to 4, I will be there at the class, but I won't be, teaching or delivering content. You can ask questions from me during that time. So you can ask questions about the project, the assignments, or any other thing that you want to know about the, IoT module. Any questions you can ask during that time. I will be there in the class. If you are coming, I will answer your questions. And I think since I think there's a 2-hour time slots that yes. Is there any comments? So I think I will do the content delivery during the Tuesdays 8 to 10. So if possible, please, pass the message to everybody who's doing the IoT module. So I will also try to pass the message as from my end as I can through an email and through the LMS. So anyway, I will be available on Friday. If you want to come and meet me, you can do so. Okay, thank you, Jitma. Yes. Have you marked your attendance so far? You Okay, so I will also try to complete the content during this month. I think only 4 weeks will remain until you get the study leave. Think. Do you know about the time that you will receive your study leave? Do you know by when you will have study leave? Can you put in the chat or you can let me know? Okay, so if you get to know about the exam times and when your exam will start, let me know, please. I will, because I need to know that. I need to prepare my content based on that. Also, I also need to, you know, eh, discuss with you regarding the exam. I think the exam will be uh, of 3 hours. So you will have some questions for 3 hours. So I will discuss with you regarding that also. So most probably in the last week of the lectures, I will discuss that. So my idea is that you will have a time until the second week of February to, attend the lectures, and then you will have the exam. So I think by February, the first week of February, I will try to discuss that about the exam and about the maybe how the exam will be conducted with you, uh, right, regarding the IoT module. So I think this is this unit 3 is something very important, and we are going to discuss about the software defined networking and network function virtualization. So I think you will learn about these software defined networks already. Maybe I don't know whether you have learned in another module. Mostly this is related to the networking side and the technologies related to networking. So maybe if you're learning modules related to communications and networks, data networks, that kind of modules, you will learn about the software defined networking. And software defined networking is a technology that is very important for IoT networks. Um, as I said before, Internet of Things, IoT is relying a lot on the internet and the connectivity with the internet. So the device connectivity with the internet is it's something that is something special and something that sets the IoT networks apart from M2M communications, for example. Right, M2M also can be extended to IoT, but when you're considering about the IoT, IoT is basically uh, a connection of devices to the internet. So we try to when we try to deploy a certain IoT network, uh, where we want to make sure that the communication that we do or the data that we send to the internet and to a certain destination is reached without any delay and with security and with other parameters, with less cost, and so on. Right. However, like internet is something like this. For example, this figure shows like abstract diagram of the internet, which actually consists of different network components such as routers, switches, and other network components. And these all these components are connected in a very, very unorganized, I would say, manner, which makes it difficult for us to determine the best way to communicate data. And sometimes our data that we transmit or that we send into the internet will get lost in an intermediate node, the intermediate location in the network. So this is a wild network, actually, very wide area network. So it is actually very complex network. When we have these kind of networks, so we need to organize our communication, and we have to organize the path that we transmit, the path that we use to send the data in our network. So if we consider the current networks, the traditional networks depend on a lot on hardware and the physical equipments. I mean, we rely a lot on network devices, network hardware devices, such as routers, switches, hubs, servers, those things, and we rely a lot on the hardware devices, right? However, now, since a lot of users are using the internet keeps increasing its size. It keeps getting complex, more and with more and more hardware equipment getting added into the network. So this network becomes large and complex, and it is made of multiple nodes and links. Right. So in the current system, we have, in the traditional systems, in the traditional networks, we have very rigid and expensive infrastructure. Right. So we connect all the communications, and we do the communication between routers, switches, and other hardware components. The communication relies a lot on the hardware, and also if there's some kind of fault in one of the hardware, we have to repair them, and we have to wait a lot of time to get it restored. So sometimes relying on the hardware is not a ideal solution. We cannot get rid of hardware, we always need hardware, but sometimes we need to use software based technologies to enhance the performance of the hardware. So we have to program the hardware such that the hardware can be used for many tasks, not only one task, and use that hardware for many tasks. So if you consider like a router, for example, if the router is only used for routing and it cannot do any other tasks, then sometimes we are actually having um, we have to we have to use always we have to use that specific hardware to do the routing. However, if we have a certain hardware or a server that we can program, um, we can actually program that server to do many functions. We can make the server do routing. We can make the server do load balancing, the network load balancing, the network security functions, and firewalling functions. If we can make a server do all the work, then we can actually use the server as the hardware to do all the network functions. So by doing so, we can actually replace the router and we can use a server. So we can use the server and we can get the same function done by the router. And not only that, we can do many other functions as well. So that is what that has been proposed, which means that we are going to use software programs to do the network functions, right? So uh, the traditional networks, if you are using the traditional networks, uh, the problem with them is that when we are using the devices for specific network functions, so specific devices for specific functions, updating and launching new products and services often involve long periods of time, right? So if we consider like routers and switches and that kind of hardware components, these components have been manufactured by specific companies that produce them. So when we are trying to connect different devices together, we have to use several standards. We have to follow certain protocols. If we don't follow them, then it's going to be another problem. And then if there's a new product coming, we have to get to know about that new product. We need to know how that product works, what are the components that are available in that device, and how we can connect the device to the current network. So those things involve a long period of time. So because of all these and other challenges like cost, when we are using a lot of hardware, we have to incur a lot of costs, manufacturing costs, repairing costs, likewise. Then also flexibility uh, of the usage, flexibility of using those kind of components is less. The standardization process takes a lot of time. So if you want to connect multiple routers and switches, hubs, and the network components, we have to follow the certain standards. So sometimes those kind of things can take time. And also network management, configuration, and control becomes a little bit challenging with the conventional networks and with the conventional hardware, where different hardware are used for different functions. So when it's like that, sometimes configuring those devices takes some time. Controlling those devices also takes some time. Management um, also requires some time, and we need to train the employees to use those devices as well. So these kind of challenges remain with the conventional networks. So the solution has been proposed as the network virtualization. So network virtualization is something that has been proposed as a solution for the problems that are there with the rigid networks that we have that rely a lot on the hardware, right? That rely on hardware. So now we are going to focus on software. How can we use software to drive the network? How can we use software to manage the network load? And how can we use the software to efficiently communicate the data uh, of a certain network and get the communication done on time? So what is the use for IoT from all these? So we will discuss how IoT also comes into picture. So IoT, I just would like you to remember that it is also a massive network that has multiple, inputs or multiple data, right? It has massive amounts of data uh, at its end. So IoT networks, I mean, it can be a small scale network. IoT networks also can be massively large networks. If there are hundred or thousands of sensors connected to the IoT network for a certain application, then uh, then we can assume that all those sensors will produce some data, and the production of the data will happen frequently, and the data uploading also will happen frequently. If that is the case, then lots of data will be uploaded into the internet. So once that happens, there's going to be a high network load added to the network due to the IoT networks, IoT systems. So network virtualization is a technology that can improve the efficiency of the IoT system or the IoT communication system. The network virtualization can be added on top of the IoT to enhance the IoT performance. Right? So network virtualization, therefore, is an important technology. And it can be basically divided into two parts: network function virtualization and the software-defined networking. Right? So we will discuss about those two things one by one. Do you have any questions as of now? I will continue. If you have any questions, you can let me know. So the virtualization concept is basically separating software from the hardware or the network equipment. So the virtualization word it itself means that you are virtualizing something, right? Uh, which means that you are you are doing some hardware function or a function that has been done using a hardware through a certain software. So how is it done, right? So let's say, like, for example, there are many network functions. So one of them include routing, for example. So routing data. So routing data means like you're transmitting data from one location to another location. So the locations that you're transmitting data, and once you know that, you need to transfer that data. And that transferring of the data can happen through multiple devices in the network, right? So if you have like a large network, you know that you are sending some data at a certain location, let's say in here, and then you want to send the data to another location. So you have to route the data from one location to the end location, end destination through multiple hops. So these multiple hops are decided through the intermediate routers. The intermediate routers decide what is the next best location to forward the data. So as of now, in the traditional networks, the data are transferred to routers, and the routers themselves decide at their location. Once they receive a certain data, they decide what is the next best router to forward the data. So each of the routers will make the decisions and will transfer the data towards the next router, and likewise, finally will end up reaching the destination. So in the software, based technologies, what we do is we actually uh, we actually do the routing through a software program. So we can actually write a software program that can do the network function of routing. So routing can be written as a code in a certain as a certain script, and that script will be installed in a server. So uh, so the network functions can be written in a software program, and that software program will be installed in a server. Right? The server can be a certain computer. The server can be a certain, like a highly performing computer. Then you create different scripts for each of the network functions: routing, firewalling, load management, packet forwarding. Those functions have been written in a code. So this code will have certain input data, and it will give out some output data. So the whatever the routing work will be defined using this uh, code, and that code will be kind of like a network function, and that function will have some input data. We will have to provide that input data to this function to get the output. So once we have each of the software programs defined, we can install them in a certain server. And a certain same server can be used for several purposes. So different functions can be installed in the same server, right? And we can install routing, firewalling, load management functions inside the same server. We don't need to separate network components or network hardware for the different network functions. Same server can be used for different purposes. So the difference between the traditional network and this